Ciaran, welcome to the QTS experience. I am so glad we got you on the show. I love how every now and then you shift your shoulders and the light comes through. If I start looking at you like you're our Lord and Savior, I'm really not, it's not wishful thinking, but it's an amazing halo effect. I love it. Don't fix it because it'll add to the memorable experience for everybody.
Okay.
But it's just the light of your soul shining through, and you can't.
Well, thank you, Dave.
Well, your accent, where are you at now? It looks like you're out on the road somewhere.
I am indeed. And look, first, Dave, great to be here with you, and thanks for the opportunity. I'm in Phoenix. I'm at 7x24 Exchange down here in Phoenix. Fantastic event. Probably one of the better events, to be fair, that I get the chance to be here in the US. To meet customers and having some fun down here with customers and consultants and the brains and the great and the good of the industry. Yeah.
What makes that event? You and I both go to a lot of events, and I measure them differently. Why that one? To be fair, I think, well, there's a couple of things, right? I think that 7x24 Exchange do a great job of curating, an interesting agenda, right? Panels and keynotes and discussions. And there's always some interesting people, on at these events, people that maybe are not directly in the industry that are bringing a different perspective. So that's one thing. But also I think the diversity of the attendees, right? It's the consultants, it's the end users, it's the manufacturers, the suppliers. So it's got a nice balance of that. I mean, there are other events that are maybe biased one way or the other. I feel that 7x24 Exchange brings a nice balance. And I think the heritage of the event it shines through a little bit as well, right? So this was always more of a learning, educational sort of slant to it, as opposed to a marketing or a sales type thing. So yeah, that's why I like it. I've been many times. I've been to a few local ones, but it reminded me of, and that's probably why I didn't give it that much attention, although all of my connections in the industry, because I do this so often, are suggesting that we investigate it more closely. But it reminded me, in the US, we have a thing called NANOG, which is a very connectivity, engineering heavy. They'll start talking about the GBICs within machines and how packet flows. And unless you're an engineer specifically in that and trying to solve a problem, it was less interesting to me to have the, a different kind of conversation. That's great to hear about 7x24. Yeah. I'll have to investigate that, because I had the same opinion. I thought it was very engineering, what's the tilt-up wall new design angle going to be at, as opposed to one of the things that you talked about, which I know we're going to get into a little bit later, digital twins, which is it's not an emerging area, but it's it's an area that's getting a lot of attention.
Sure.
We'll dive into that.
Yeah. Yeah. And Dave, just on that, the 7x24, it's the 35th anniversary. They've been doing this since 1989. And I was talking to somebody last night, and, I've been in the industry a while, right? Not that long. Right. I kind of didn't know we had an industry in 1989, quite frankly. So that was cool to learn that.
That's right. I can imagine 36 years or 35 years ago, people are looking around, do we have an industry? Like what are we doing?
Yeah.
Hey, let me ask you this. So you and I have recently met a few months ago. I'm not that familiar with Siemens infrastructure in general. I don't know much of your story other than what I've heard from the stage, what I've read. Can you start us off with how you got in this industry? That's always a great story. And what role, not necessarily, although you can tell us what's going on with you and your organization, but how is Siemens interacting with the critical infrastructure world that we're dealing with now?
Yeah. Great question to start us off, Dave. Thanks. So my background, I graduated with an engineering degree. My background is in the semiconductor industry, actually. I started off in semiconductor, and then over time, I the way it is with careers, people, I don't know if there's a career plan. I certainly didn't have one that would have predicted how I would have made my way through industry. But sort of by accident, I was working at Intel, and by accident, I kind of fell into the data center function in Intel. And from there on, I started to sort of pivot, to use that word, away from the semiconductor industry and into the data center industry. So I variously worked for Intel here in the US. I've worked for ABB. I've worked for Nokia, a couple of other smaller roles in between, and now I'm here at Siemens. Look, it's been a fantastic industry for me. I have to, I've really enjoyed it, and I hope to enjoy it lots more. I mean, when I think about this industry, what I get most out of it, and it's probably why I'm here now at Siemens, is that it's an industry that really tolerates curiosity, right? It's an industry that innovates. I mean, some of the stuff that goes on in this industry is fantastic. Some of it not well known, right? Some of it happens in the background by small companies, and you got to go find those small companies. But for me, it's really all about curiosity. And what better time to be in the industry now at this major shift? And we'll get into it, Dave, I'm sure. But this major shift from the CPU age to the GPU age, and how that's trickling down into changing the shape of the industry as well. So today, I'm at the moment, and presently, I'm with Siemens Smart Infrastructure, and Siemens. See, I've been here about just short of 3 years. Siemens have been in the industry for many, many years. In fact, as a young engineer in Intel, when we were doing data centers, we used Siemens technology. But I guess it's probably only in the last 7 or 8 years that Siemens started to directly engage the industry because of the scale of some of the clients. So I run that business globally. We do electrification, we do control systems and software, we do fire protection, fire safety, and security. And then around that, we've got some services that relate to finance, Siemens Bank. We do digital transformation with some of our clients as well, where they're trying to shift their operations from being analog clipboard the way they always did it in the past to something more digital, and we can get into that.
Yeah.
And then we've got some consulting around decarbonization as well. So that's our offer in the industry, and it keeps me busy, and we've been growing like gangbusters now for the last 3 or 4 years. And yeah, I think we're going to continue to grow. We're absolutely going to continue to grow, and I think the industry is exciting, and it's expanding, but it's also changing, and that's probably again the curiosity thing. I'm always looking out to see if I can figure out what's changing next.
Yeah. Well, if you figure that out, let me know. If
no
you
chance.
could let us 2 years ahead of time. It feels like every 3 or 4 years it changes, but you threw me completely for a loop. I'm glad the cameras were recording because you told me you worked at Nokia, and one of my favorite in my early days at QTS, I'm one of the original employees here. We got to work with the Nokia folks. They bought a local organization here in Atlanta. They came in and they said, "Yeah, we've got an international frame agreement with your competitor. We're just here to, as a matter of courtesy, we're not going to use you guys." Well, they ended up using us. And that's not what I remember. What I remember is they brought Finnish licorice.
Oh, wow.
And they're like, they gave us a taste at the negotiation table. I didn't realize it was a tactic to completely mind boggle me, which they did. It was so delicious. It's like Turkish delight. I still twitch whenever I think about it. And that's almost 20 years ago. So those guys.
Well, just so we appreciate how small the world is, Dave, when I was at Nokia, I visited your facility in Atlanta. As your customer. So we may have crossed paths.
We probably did. How small. I was the original, smaller yet, I was the original solution engineer that built the environment that Nokia bought. And then when they first began evaluating us with their US folks, and then some of the international folks came over for the later phases, and then the contract negotiations, I was part of that entire thing. And it made me want, I come from a cloud background, work at the University of Texas. And then at that time, QTS was very much a co-location provider.
Yeah.
While we were in a data center, we were all into the high touch managed services and all that other stuff. And that was my whole background. But as my experience with Nokia, I said, ooh, I want to learn how to do this thing called metered power. And I want to learn how that we weren't, Christian hadn't invented PUE yet, but these other things, this kind of negotiation, because this seems like this is going to be really important. We called it wholesale back then, but it was the early days. That was, I don't know, probably 2009, something like that, 2010. But it was a lot of fun. All right, we're getting distracted.
Yeah, we are.
And I'm looking at the clock because you've got to be somewhere. Otherwise, I could do this all day long. Hey, you said something the other day that really caught my imagination. You were talking about it from a panel, And you know how these panels go. There's several voices up there, especially if it's somebody as obnoxious as me, and it's difficult to tease an idea all the way out. But you introduced this idea that I wrote down called the energy trilemma and AI's impact. How would you describe the energy trilemma? And why don't we start there? How would you describe it? What do you mean by that idea?
Well, the energy, obviously energy is the driving force, or one of the driving forces, behind the industry. I think, look, everybody's looking for reliable power. Mm-hmm. They're looking for power at the right price point. Mm-hmm. And more they're looking for decarbonized power, mm-hmm. right? And, as the energy markets evolve, and as the energy markets bring on more renewables, more diversity in supply, that transforms the energy market's ability to supply. But the reality we're in now today is that our industry is now growing faster than the energy industry can bring decarbonized power onto the grid, right? And that's why you're seeing, some of the hyperscalers are starting to look at, essentially signing super PPAs for nuclear, or really making investments to try and catalyze the utility and the energy markets in certain geos to help respond. So when you look at that, and some of the hyperscalers have been very open about this. They've said that they're starting to go a little bit backwards in their sustainability metrics, because they've brought on so much capacity over the last 18, 24 months in response to AI. That they've had no choice but to, onboard energy that's not decarbonized. That's, it's from a grid that's, got some carbon content. So that's the reality. And then you think about it like a triangle, right? Each corner, cost, reliability, and decarbonization. And where's the priority? Well, it's all a priority, right? The industry needs reliable power at a price point that's commercially viable, and they need to decarbonize. Mm-hmm. AI has really upset that journey, right? So up to 2 years ago, we were on a path. We were adding a certain amount of capacity, and while the energy and the utility industries and the generation industries weren't keeping up quite with the path, they were a lot closer than they are now. Mm-hmm. So the question is then posed: Is AI going to set us backwards? And the way I look at it, and the panel you were talking about with Ciaran,
Ciaran Petersburg.
Ciaran Petersburg. Yeah. The reality is, right now, today, we're not keeping up. Right. And I think as an industry, we have to be honest. So when we talk about, decarbonization and sustainability, I mean, I think as an industry, we got to be mature enough to put our hand up and say, look, we're not in a great position today, but let's talk about what the future looks like. And for me, at least, I'm optimistic, right? I think we will innovate on a whole number of fronts to make this happen. But we are entering, this new phase of the clean energy age anyway. Solar continues to become more competitive. The option of bringing nuclear on board becomes more viable. And at some point in the future, the AI pitch, right, the big graph going up is going to start to moderate a little bit, and the energy industry will start to catch up, and hopefully at some point in the future we can get to a more stable situation, or a better situation than we're looking at right now. So I think we got to be a little bit patient for the next couple of years, and I'm really excited actually about the opportunity, not just in the data center industry, but also in the energy industry as well, because the bringing on renewables is absolutely the path to sustainable data centers. And I talk to customers all the time about what can we do about sustainability in our data center. And I learned very early in my career, at Intel, they're past masters at this continuous improvement. Every watt matters, absolutely. Anything you can do to save energy, to decarbonize in your construction, in your design, in your operations, go after it every single time. However, know this: the biggest impact on your sustainability performance will be the energy you buy. That will be the biggest impact over the lifetime of your data center. So, the energy you buy, plus what you're doing in your data center, and the energy you avoid using through energy efficiency, that's where sustainability will happen. Certainly on the on the power side. Same on water. Yeah.
One of the things that you said, that's a great explanation. Thank you. I would just, as you're describing that, I'm imagining this triangle, but I almost imagine as a pyramid where at the top of the pyramid is safety. So you've got those three things with safety. Like, I've come across plenty of conversations or many conversations where in pursuit of one of these quadrants, sometimes safety isn't vocalized. I don't mean that they don't mean to not be safe, but it's one of the things that we're constantly, not just for ourselves, but trying to remind our frenemies, whatever we're doing, let's keep thinking about safety. It's so easy to get, because there's a lot. Like, and in the
absolutely.
When you were describing so many of these things up to now, we're just talking about this trilemma, not casually, but we've got this and with this. And for people who aren't near our industry, like we're talking about really hard things. We're talking about, how we develop energy sources. We're talking about how we partner with public utility. They've never had to go through this, much less the staff and the sophistication of the tools and data centers moving at scale and speed. Like, and not just us, we're looking at reshoring infrastructure. That is also going to be the draw. And like, it's hard. And so when you were talking about this season of curiosity, I would just say amen, but you also have to want to, you got to have an attitude of let's get in, not just be curious, but work hard, because our curiosity is going to lead us to, well, we got to do this thing.
Yeah.
And then lastly, we can't solve anything that we don't talk about. Like, how do you navigate if you don't have a truth or a fixed point of reference? If a sustainability goal is going to push, well, then let's evaluate it. Does that mean we slow down on the development? Some groups will say yes, some groups will say no. If that's not an option, then do we spend more capital to accelerate certain things, whether that's the super PPAs or whatever? Like, how do we work towards these things, and how do we empower the innovation teams of the things we do have control of right now to get as spectacularly efficient as possible? And this AI infrastructure we're building, how do we turn it loose on ourselves to find opportunities within ourselves? And I know we're going to talk about more and more of this, but as you're describing it, I'm totally nodding my head. But I can imagine some of our listeners like, this sounds easy. Like, it's a challenge.
So there's so I was with some consultants last night, and we were talking about nuclear, right? And we were talking about what it means to run nuclear power facilities. I have no idea, and I dare say. Do
you mean big nuclear, or do you mean small modular?
SMR, nuclear, just conceptually. But that's going to be a highly regulated, long lead, very safety conscious type business. And I dare say the data center operators won't run the nuclear reactors. It'll be done by the experts, and the data center community will sign the super PPAs. But it will bring a new dimension to how we think about the data center, for sure. For sure, it will. Yeah, absolutely. And we strayed then into kind of economics, and somebody was reflecting the .com bust we had in 2001 or whenever it was, just when I joined the industry, or just before I joined the industry. And an interesting point, and we were teasing this out. Wouldn't it be so ironic if, let's say, we're on the point of this AI boom, and the boom got boomier, but actually the only thing that constrained us was the fact we couldn't get power? That the utility industry saves us in a way by keeping us a little bit more measured and reasoned about the rate at which we bring these facilities on. I'm not saying that the boom is going to bust. I just think this growth is being constrained right now by the utilities' ability to get us power.
Sure.
May not be the worst thing in the world in the grand scheme of things, and it'll give us time to let the renewables catch up, as the years go on.
Yeah. Well, look, I think that's true of any industry. There's a lot of arguments by any actuarial table you look at, any conversation, all things being equal, at least in the United States, with our complex interstate and very large transportation. If I had solar powered or hybrid trucks that are near autonomous or mostly autonomous, there's just so many studies that show how efficient this could be. But there's constraints, and so it's not an intellectual thing where we disagree. It's just a matter of making it happen. And so,
the practicality of it, absolutely.
That's right. So things accelerate or decelerate based upon whatever the variables are. The one thing before we move off this topic that I think is super important, I love where you're talking about this, is whatever future energy looks like in its relationship with any critical infrastructure, data centers among them, it must be a healthy, transparent conversation with the utilities. The utilities are not our enemies. They are brothers and sisters in arms. And we must be in it together, whatever the source of energy is, and maintain that curiosity to any and all available energy, including the necessary storage. And are we serving base load? Are we not serving? There's a place for all of these things to play. And then with the communities that we're going to operate in, the citizens that we're serving. And so, it now is back to this, we were mentioning 30-something years of an industry. Well, now nobody talked about data centers 5 years ago. I mean, us nerds did.
Well, certainly not 10 years ago.
Certainly not 10 years ago.
Dave, I remember being in this industry 20 years ago. Nobody talked to me. Nobody in the executive office.
Don't date us too much.
I was in the basement. Nobody spoke to us. But you touch on a good point, right? And this is something that I think we should be mindful of. I kind of feel like handing out the olive branch or the UN here. The energy industry is going through as big a transformation as we are at the same time. So it's not just about our transformation and how we make this work. We've got computing is transforming for sure, and we see that.
Right.
Clean energy and the energy industry is transforming. Electrification everywhere is absolutely the future, or in most places. And then science generally, right? So all of these things are happening in the background at the same time. So I think it's an exciting time, and I think that the path to that equilibrium that we will see in 4 or 5 years' time, maybe not so clear just yet, but I think we're getting there.
It will be unnecessarily burdened if we treat it like opponents and not teammates trying to find a way and give each other grace. And I love to hear what you're saying. And more people are sort of, because a couple are saying the same thing. A few years ago, Buddy Reiser is also a champion of this out of Loudoun County. People got surprised. The utilities got surprised. Everybody got surprised. I just think that's, it's and I don't want that narrative to change. We got surprised by the speed and scale of demand and these other things. So people got surprised. So instead of, we're now shifting, I think, more and more from an attitude of you should have known better, or why didn't you know, or you made these stuff. We don't have time for that. How do we do this thing where we are accelerating to accomplish the things their strategic initiatives for industry, their nation state initiative, this is important stuff. And it doesn't just serve our data centers. And so long as we have that, give each other grace. I mean, it's, there's a little contact, but that's okay.
Yeah, no, absolutely. Yeah, Dave. And look, let's be honest as well, right? The data center industry is probably, I think, is still the biggest purchaser of power purchase agreements. So the data center industry has been forward in underwriting this energy transition. And I give credit to the large hyperscalers for doing that, right? Some are more transparent than others, but generally speaking, they're driving this transition as well. And I think that's fantastic to see.
And they're driving the operators like us to do the same thing. So that's a lot of fun. But hey, before we get off of this topic, and I'm already looking at the clock. I'm like, gosh, we've only got 35 more minutes to go, and we're on question 3. So we've kind of danced around this a little bit, but when we talk about AI, first of all, I would say there's a whole, I think, at least in my case, I get hypnotized by artificial intelligence and its impact, whether it's training or inference or whatever. There are a lot of things that are impacting the growth of this stuff. But AI seems to be certainly getting the most attention. It seems to be the talk of all the boards and advisory councils that we're participating in publicly or privately, mutually having conversations and figuring out everything from how do we cool it, mitigate the heat, design, build, operate, afford it, capitalize it. Why do you think, how do I want to ask this, is how is this particular challenge so different than any other technology that's going into the data center? Why is this one so disruptive?
Yeah. So I think there's probably, when I think about AI, I think about it on two dimensions. I think about the demand side, right? The demand for AI, right? New technology or new applications, all of that. But then on the other side, the impact it has on how we design and build and run data centers. The fundamental shift or the fundamental technology change is that we're packing much more, technology into the same space, and the power density changes fundamentally. So we call it the 10x challenge, right? So you go from the power you had in your data center today to 10 times the power tomorrow, in theory at least. You go from the structured cabling you had today to 10 times the structured cabling tomorrow. The same with the heat dissipation, the heat rejection, right? So it's all driven by this densification of technology. Now, early on in this kind of shift, I was like a lot of people. I mean, I was trying to figure out, what do I think about this? And over the last year, I've kind of come to a couple of my own, I guess, conclusions. AI is absolutely the next phase of our computing, of our understanding of computing and what we will do in computing. So this is something we have to embrace. It's not going to be, we do it for a couple of years and it goes away. It's not that kind of technology. It's not, like some of those, I guess, 3Gs or 4Gs back in the day that didn't deliver everything people thought they would deliver. When I talk to customers though about AI, they're genuinely trying to figure out what to do next, because there's a lot of information in the market saying that, when you go over 30 kilowatts, you got to do water cooling. You can't power it at this voltage. You got to do something different with your UPS design because of power swings. All of those things to some degree or other could be true in certain circumstances. But what we're finding is that it really depends on how you're deploying AI. If it's just a part of your existing infrastructure, if you're building specialist infrastructure that's going to be just AI, if you're going to build in certain geographies, you might take a different approach to the cooling and the heat rejection. All of those things play. I was at an event in Singapore recently, and I was trying to take a practical view of what a designer or an operator should be thinking about today if they're getting on the AI journey. And we kind of teased out 4 points. So number one, AI is creating significant power swings in your data center infrastructure. We're talking about megawatt loads sub-second, driving the utilities crazy, potentially affecting the reliability and the operations of your electrical infrastructure. So again, knowing this, going into this with proper power quality and proper metering and proper instrumentation is going to be really, really important, because it's not one of those nice even loads. The second one is clearly the heat rejection. So back in the day, if you had a heating issue, if you had a cooling issue, you might have an hour, 30 minutes, 4 hours to manage your thermal runaway, to get things shut down, to deal with it from an operational perspective. If you've got 80 kilowatt racks and something happens, you're like Icarus. You're going to be close to the sun pretty quickly. So how you manage that is going to change, and the whole risk profile of that is going to change. And that risk profile is also feeding forward into how you think about fire safety in data centers. Corporate insurers are asking, what does this 10x density mean to fire risk in a data center? Now, at this point, they're only asking. We haven't really started to answer it yet, but it gives you a sense of where this discussion might be going, because these will be super hot facilities, right? If something goes wrong. And the last one that I think, and we touched on this at the event here, cybersecurity is going to be significantly challenged by AI. The bad actors will be using AI to automate and replicate and propagate at a rate and a sophistication that they couldn't do previously. So all of these elements come together, and I think this is what when I talk to data center constructors, designers, and operators, this is what they want to hear about. They want to hear about the practical reality of what it takes to deploy an AI infrastructure, and it's exciting. I think that, quite frankly, from a technology point of view, there's many technologies available, many approaches available. It's really a matter of figuring out, in your particular instance, which is the most appropriate one for you. And my hats off to NVIDIA, and I spent some time with NVIDIA at this event as well. I mean, they're investing in and they're engaging with the supplier community, like Siemens, like our competitors, to make sure that we have that dialogue about bringing the right technology to take these risks away, to make sure that our customers and our industry can manage this shift in expectation around power density and sophistication.
There's so many good things there. My hand's cramping. I'm writing stuff down. I love it. So you're just gonna have to skip your appointment and hang on for 2 more hours.
That's okay.
But we won't do that. But a couple things, especially sort of a theme as you've talked through this. And you started with curiosity, and I'm going to get to some of these points. But one of the things that I love is we're so very fortunate, and this, we're not going to be an infomercial for our companies, but I love to hear what you guys at Siemens are talking about. It reminds me of us in this way, because we started off as a co-location provider, building customers' networks that we didn't touch their data, but everything but their actual data. And so we had to understand them. We had to understand what business problem we're trying to solve, create a technical solution for it, and then be literally their people within their environments as they're operating their environments, whether it's preventative maintenance or whatever. And as you know, over time, those got more and more sophisticated, up to and including when we began building our own private clouds before the big public clouds even would do FedRAMP or FSMA or the big, nobody would consider that in a public way for production. They eventually, of course, did and dominated the world. But what that training ground for us was, we had so many people, because we had to learn how to balance compute, network, storage, physical security, logical security. Where do we demise it? How, concentric zones, all of these things. And here's what happened. I think you're describing the same thing. When you're talking about these swing loads, it's not just massive loads, but they're a microsecond. And people are kind of scratching their heads like, how do we do this? And the blockchain guys come wandering over from next door and say, instead of getting a bunch of load banks and a bunch of heat sinks, we just do crypto or block or whatever over here. And if you did that, and then we put switch infrastructure, it's just sort of scratching out, like they're eating a scone and they're drawing at the whiteboard with our nerds sitting next to them. And they're like, and it's almost like the NASA engineers are like, well, that work? Could we get to Alpha Centauri doing that? I don't see why not, because the load then is, this load is, has these swings, whatever, but you can pop it over here, you can pop it back there to the grid. It looks like a big heat sink and it's going. But now so for sustainability, for intermittent power, for these other things, for these switches, like, it's a way to start. What do you think? And then they wander out, shirt untucked, butter dripping down their chin. And we're like, we just got blockchain. I don't know what just happened to us. But it's that, it's that kind of mindset. Like, you've got to be willing to and whether that gets adopted or not, the point is, how do we rearrange the existing Legos? How do we make new Legos? Or how do we just let people who would normally, I don't know, maybe you make the fans in chocolate or whatever, but they come in and you start kicking around, but you've got, most of us have some kind of an ego. And so it's this crazy balance, almost like a stallion under power, that knows it's powerful, that knows it can go to war, that knows it's got, when you call on it for its mission critical thing, but it has humbled itself to work with the team. And I know that's kind of melodramatic, but just the people I think that are going to be in these unprecedented times of software innovation, of hardware innovation, of tool optimization, of managing the wellness of our people, all of these things are all being adopted, evolving in real time.
And in parallel.
And in parallel. When you mention Icarus, I'm like, once upon a time, you see an Icarus flare out. Well, now we don't want, Icarus is going to flare out in a heart of a bunch of Icaruses instead start off a chain reaction. So, and then I would just add this one last thing when you're talking about new fire considerations, for example, here in our state in Georgia, everybody wants to electrify. I'm one of them, getting vehicles in. But there's been some really interesting conversations around, do you realize what would happen? My neighborhood's probably 30 years old. If everybody in my neighborhood, their primary vehicle was an electrified vehicle, what the impact to our transformers would be. That would not be insignificant. We can solve that problem, sure. But if you have a massive lithium ion battery fire in your garage, we have one fire station within 25 miles that could deal with one fire.
Yeah.
So how do we, and we're not a remote, we're an NFL city, we're, remote. And so it's just these compounding things as we try to think about how we solve them. How are we curious to work with each other? Because we know we want to do this. Who would want a gas station up the street?
Yeah.
But we run into these, whether it's laws of physics or just new ways of thinking things. And so if you're not a hard worker, and if you're not curious, and you're not interested in collaboration and saying, ooh, I challenge your idea may not, I would expect 80 to 95% of the first phase ideas aren't going to make it off the stage.
Yeah.
But bring them up there and let's have fun.
And let's see.
Yeah. What's the concept? I'm sorry, go ahead.
But even on that, right? So a couple of things there. And I don't have, any expert insight on this, but yes, of course, fire risk, that's one area. Mm-hmm. Fire detection is a constantly evolving science as well. How we detect fires, the things we can do now with atmospheric testing to predict the state of a piece of infrastructure, the way we monitor infrastructure so that we can see if things become more of a risk, the way we will use AI models in the future to learn about the state of a complex infrastructure and to correlate events and changes in performance and draw conclusions and give hints and maybe recommendations to the users that, okay, something's different going on here. We're seeing some interesting change in behavior in your lithium-ion battery. You might want to go check it out or turn it off and get it serviced. So I think we will get better at that. Right. And the other one, just in AI, the AI thing, and this is something I've started looking at as well. Extrapolate, right? Let's say accelerated computing and AI can do many, many more flops per watt than let's say our traditional architectures today. And then imagine for a minute that we can move in the future, we can take cloud workloads off the current infrastructure and put them on an AI or an accelerated computing infrastructure, and we can do the same work for a tenth of the energy. Mm-hmm. What does that mean in the future? Does that mean that the cloud infrastructure will all go onto AI infrastructure and become more efficient? I don't know. I really don't know. But I think these are the kind of things, as we innovate as an industry, as we look to solve these problems, these are the kind of things that start to bubble up. And to your point, exactly, Dave, 85% of them will bubble up and fall off. But in there, there'll be a couple of gems that can help us get to the next stage, without burning the planet or using everything or poisoning everybody.
Yeah, we were just moving a TV in my house, and I remember when I bought my first plasma, which I think bowed the wall in my house. When you turned it on, the lights all dimmed. Yeah. It was probably $3,000. It was beautiful. The other day, we moved a television that's twice as big, 1/50th the power draw. You could see, it's like an 8K TV, so you could see the hair follicle on the back of the water buffalo. Like, why you would need to see that, I don't know. It's so light, like in every way, the material is infinitely more recyclable.
Super point.
But we've just made it giant. And so my wife and I, the other day, it's just two of us sitting on the couch. Our kids are at school or out of the house. So we're like, why? We just, we're on our tablet this whole time. But let me ask you this, because I keep saying we're going to run out of time. I'm looking at it. I'm going to force you for another 20 minutes. But what's the consequence, do you think? If we don't, we will. There's no doubt in my mind we will ultimately solve the energy challenges. I'm not just a optimist. I think even as a realist optimist, that we just will. We always have. We always will. But what's the consequence of being late or not doing this in a transparent, communicative manner? And then I want to move on to digital twins, because I'm fascinated by this conversation you just had. But just to kind of wrap this up. If we don't, it's not that I don't want to say we're taking it seriously. We are, the whole world's taking it seriously. But if we don't get it right, if for some reason we don't talk, at least in back channels, as competitors, as industry leaders, if we don't do that in a way that really helps facilitate all of this innovation, what's the consequence?
Look, I think fundamentally the consequence is that we will either constrain the growth and the expansion of our industry, which will mean we will probably miss out on some of the potential future opportunities that accelerated computing and AI and computing in general can bring us, right? I think that's absolutely one consequence. I think another potential consequence is that we miss the opportunity to really educate the world at large, communities at large, humanity at large, about the real good and the real benefit that computing and technology and ergo data centers has brought and will continue to bring. And I think the last piece of it is, quite frankly, we're kind of out of options. I mean, decarbonization is an absolute necessity. It's an absolute necessity. And, I again, to go back to client conversations, the most decarbonized watt you can have is the one you don't consume. That's why energy efficiency is so important. But if you look at the grids around the world, if you look at all our quest for more power, right, more energy, there's a lot of stranded power in grids everywhere around the world that we will liberate over the next 10 years as we transform the grid and we drive these grids with more sophisticated software and, dare I say it, AI-driven software,
right?
So that we can get the best out of the energy we have, right? And sometimes when I'm in an airplane, I'm landing and I'm looking at a freeway full of cars, and I'm often thinking about the amount of energy sitting in gas tanks at any point in time, on a freeway. It's latent there. It's just sitting there until somebody uses it. And I kind of have the same feeling about our electricity grid in the global sense, right? There's pockets of power available that we can't get them to where they need to be. And there's areas where we can't get enough power. And, we maybe have the wires, or we don't have the wires yet, but we'll get the wires. And then we'll have software that will federate and aggregate and stimulate, and it'll do all of the grid leveling like we're doing in smaller grid contexts today, but that will expand into a bigger proposition, and it will be AI driven.
I love it. 45 minutes. We're through 4 questions. We're killing it. Let's talk about digital twins. For people who may not be familiar with, now all my online racing buddies, they're familiar with digital twins because LiDAR and all of that is used to make Formula One tracks, to make racing cars. My buddy John Henry, who owns the Boston Red Sox, their little baseball team here in America, he owns a online racing league called iRacing where they rate sport. You can get it's literally you're racing a physics model, and they use digital twins to make all the big racing teams use these things. When you think about it in the context of Siemens, whether it's how you support data center infrastructure or just your own initiatives, what is a digital twin, and what does it mean for your organization? How are you applying it?
So when I talk about digital twins to anybody who listens to me, which sometimes people will, let's say. So I think about digital twin. I think about when I was a kid with my computer playing Microsoft Flight Simulator.
Oh yeah.
That right there is a digital twin, right? Sure. It's a digital representation that you can manipulate, that you can parameterize of something in reality. Now, obviously, it's a very simple digital twin, and it's a very simplified version of digital twin. But just for context, to get us thinking about what digital twin is, it's really a digital representation of something in reality. That's what the twin is. Now, what do we do with the twin? At Siemens have been doing digital twin for many decades now at this stage. Right back to early stage robotics in automotive, chemical, oil and gas, those kinds of applications, and we do it with customers, so customers can model what they intend to do and can start to understand what the impact is of the change, of the construction, of the configuration, of the operation of anything from car manufacturing plant to a beer bottling plant to a power station, any of those things. So from an operational and an engineering point of view, it allows the customer, right, to understand his environment in the digital world first, and then apply it in the real world. And there's a whole bunch of efficiencies, and we can get into that. So what's happened over time is that capability has matured. It's matured, as a function of Moore's law, right, with computing, and it'll continue to mature. And I would argue now that we're entering an age where digital twin is going to be so effective, it's going to be so efficient, it's going to be so data rich because of the underlying infrastructure that we can run it on, like GPUs and AI and accelerated computing and all of that. Digital twin is going to be so feature rich and so data rich that it's going to open up new possibilities for what we can do with it, right? So I think then about the data center, the practicality of the data center. So there's sort of 4 phases that we talk to our customers about. The first part of the digital twin is in your design phase, right, where you start to lay down in a software context all of the mechanical equipment, all of the electrical equipment that you're going to use, the engineering parameters, the characteristics, and you start to model the behavior of your systems, right? And that gives you confidence that, okay, you're designing it right. Then you move to a digital twin concept called building information modeling, where you start to represent everything in 3D. You not only have the characteristics of the technology, but now you've got the physical weight, the physical size of it, the weight of it. So you can start to figure out how you lay these out, and you can detect if there's no room for something, or if something is overlapping. They call this clash management. And you got these levels of design in building information modeling, and that generates your construction plan or your build plan. And whether that's a data center or a car factory or a bottling plant, same thing. It generates what you're going to build. Then you move on to digital twin. You can start to simulate, right? So you got your digital twin of your data center, and you say, okay, maybe I'm going to change this around a little bit here. I'm going to move this here. What does that mean? What does that change? What happens in the digital twin when you do that? And that will take account of everything from airflow, temperature, energy consumption, comfort for employees, light levels, everything, right? The whole sophisticated package of what it takes to run a data center. And then the last phase of digital twin is one that I'm excited about. And I said something at the event that I'd probably get a smack for at some point, but I'm beginning to wonder if digital twin is going to be our new way of describing data center infrastructure management, right? So all of the data you've got from your design, from your building information, from your simulation is now sitting there, and it's there available for your operations people to really understand and engage in real time with the facility. So now you don't have to, go to separate, load of different systems to try and find out different things. You've got the digital twin, and the digital twin, with the compute power that's available to us, Dave, it can pretty much consume all of the necessary data, right down to your server types. Everything can be in there. Right. And you'll be able to move racks around. You'll be able to simulate a power failure, a cooling failure, and you can sit there with the digital twin and you can watch what happens. So I'm super excited. I mean, I think every industry is heading towards this concept of digital twin, because if you're a construction manager, if you have a good digital twin of what you're going to build, you'll probably consume less materials. You'll probably need less labor on site because you won't be doing so many rebuilds or changes. Yeah. If you're an operator, you can really start to understand how you lay out your data center, your equipment to be most efficient in terms of use of space, use of energy, heat rejection. The possibilities, quite frankly, are probably boundless at this stage. But underlying this, and this is why I'm excited, the capabilities that digital twin is going to achieve or get from accelerated and AI computing, it's going to be fantastic.
Well, you're leading the witness, because I've got a question for you. Things recently happened. So one, I love it. My experience with them outside of our industry is both flight sim and online racing, and for all of the reasons that you just described. And they can design everything in the track, everything in the weather, everything in the vehicle. So they do this, or the airplane, whatever, or the data center. But I am not a digital twin expert, and I am not a AI. There's another group. I think they're adjacent or parallel, and it's this there's organizations that, whether they're on the mechanical side, electrical side, whatever, they integrate within the management tools and infrastructure of a data center. And what they will say is, when appropriately integrated, you will be able to operate the data center as if it's a software-defined data center, meaning that you're making decisions in real time. So right now, when I have all of these things that we talked about, we spec them out in a digital twin or whatever, we've got tolerances and boilerplates of every, weight loads of racks and fan blade speeds and everything you can imagine, going valves, opening and closing, and all this other stuff in a facility. and we simulate it and we go through all of these other things. And then so that's one group. And then the other group is saying, and I'm not saying they're different groups, but these are the two discussions. The other group is saying, okay, so look, yeah, you can model that. But what we want to be able to do is between where we're going to get that maximum efficiency is not where I'm managing to a range. I'm managing to a specific in real time at a scale that humans just can't keep up with. So if I've got my 1 million square foot facility in Atlanta that's now 4 times larger, I grew my staff by 25 or 30%, but I didn't make it 4 times. And not only is it not just larger, it's exponentially more complex. And then when we add liquid cooling and all these other things that we want to do into it, but still with our sustainability and efficiency goals and all these other things, it's an intricate platform. So here's the discussion that I overheard. One group is saying you need that real-time software, not the digital twin, doing this stuff in real time. Yeah. And the digital twin, and that's going to be more accurate. And the digital twin folks are saying, I'm setting up a straw man, but the digital twin guys are saying, absolutely not. First of all, to your point about build of materials, the single number one thing, at least in building a data center, that's the most impactful to schedule is rework. It's always rework or schedule delays because somebody not just did the wrong thing, but a material didn't show up or people built something out of order or whatever. And so that twin can make you the schedule of materials. It can make you the schedule of construction, all of this stuff. How do we get these? I don't know that they're disconnected. I'm just becoming familiar with this organization or this discussion, but it feels like there's maybe much ado about nothing. I'm hearing something that's an anomaly, but try to get this real-time operation integrated with the potential of digital twin that said, this is what it's supposed to be, and this is what modeling says. Here's the report of what's happening now in real time, and how do we get those to play together?
So what you're touching on there is this is the promise of AI. This is the promise of machine learning, right? So if you think about firstly, I think that we would, as an industry, and I'd be the first to say it in Siemens too, we can't do everything, right? We are not the experts in everything. So this will all be about open platforms, open communication, open protocols, and you will have different elements doing different things, and they will all aggregate up to a pane of glass or a kind of an aggregation there that will gather that data. Now, the question that you're asking is, how does it work in real life? Think about it like this. You've built the digital twin of your data center, and the digital twin is running with it's executing with a set of parameters, right? But it's also picking up all of the data from your energy meters, your temperature sensors, your IT equipment, and it's constantly evaluating how close its performance or its representation is to the reality. Mm-hmm. And in the past, what would happen is, I've done this before, right? You'd see, the electrical meter on panel X is at a different level, and you'd go, oh wow, that's interesting. I wonder what's going on there. And I go into whatever my digital twin platform will be, and I would change the setting to make it look more like what's going on. This will now happen in real time. We have the compute power to be able to do this in real time. So the digital twin will constantly learn with your real operation to accurately represent what's going on. And that's going to give you confidence, right? And if you're sitting there with a digital twin that you feel is 99% representative of what's going on in my data center, and I decide I want to add 10 more racks of 80 kilowatts each, and I drag and drop, stick them in, see what happens, I'm 99% confident that whatever behavior change I see in the digital twin, I'm likely to see something very similar in my real data center. Right. And that's how I start to plan. That's how I start to understand the implications of change and upgrades and modification on my existing operation. And I think it goes back to the Icarus thing, right? Because these facilities are so much more power dense and are flying so much closer, let's say, to the technical limits that we're used to today, we're going to use digital twins to manage that risk. Mm-hmm. We're going to use digital twins to help in communication. We're going to use digital twins to predict and manage potential failures before they happen. That's where we're headed. And I think it's not a data center question. It's an industrial question. Right. At Siemens, we talk to other industries. They're doing this. This is how they run their operations today. And I think we're getting on that journey too.
Well, I'm going to get you downstairs on time in about 10 minutes. But my first question, I got a couple left. My first one, this isn't even really a question. I'm just fantasizing about if I get a digital twin, I want your accent for sure. Second,
sorry, Dave, think about that medical science. You will have a digital twin. There will be another Dave McCall on a server.
On a keto diet. I'll tell you that right now.
He'll figure it out for you.
Wondering around a few extra stone of, as my British friends say. I'm like, I'm, nobody likes to see the Stay Puft Marshmallow Man, even with headset on. Hey, so what is, so with this promise of something like digital twin or whatever name we want to label this thing that we're talking about, like what's the obstacle? Why hasn't it been, more quickly adopted? I mean, Siemens has been doing, maybe not in this specific, very young industry, but they have been applying themselves and people like you for a while, a wide variety of people in a wide variety of industry.
Yeah.
What's the challenge with the adoption rate in a sea full of, in parallel, a bunch of other challenges?
I think there's probably 2 or 3 elements to answering that. I mean, I think in the past, data centers would not, data centers, with your data center with your 3 kilowatt rack and, power density where we were, nothing much is moving. It's not like a manufacturing plant with robotics. It's not like, like a bottling plant or even a utility provider. So the concept of digital twin, while it was available, the value proposition probably wasn't as rich in the industry in the past, right? That's one thing to consider. The second thing to consider is how digital twin is evolving and how you can get so much capability out of relatively so little compute horsepower, right? In this efficiency game. So we're kind of getting to a point of why wouldn't you? I mean, this is really a neat way to to manage your infrastructure. And I think the third one is that as our industry evolved, we were very atomic. Right, we had server rooms where we ran applications, and we had an IT department. Now data centers are very much the fabric of enterprises, and the need for to communicate, but also to manage these risks has become much more acute. And quite frankly, from a risk management perspective, digital twin offers so much potential, and will offer so much more, Dave, as it evolves in this new world of accelerated computing and AI. It's going to become so data rich, so feature rich, so dynamic, so real time, that we couldn't do before. So I think we now have a situation, and everybody says to me, is it going to take my job? I don't see evidence of that. Yeah. Maybe I'll be wrong. I mean, I see evidence of all of our customers, really struggling to manage what they've got today with their workforce. It's really difficult to onboard and hire and develop, that experience. And digital twin will help them. It will be like their partner, right? It'll be like somebody that helps them be more efficient in making decisions. Decisions will still sit. A lot of decision making will still sit with humans for a whole number of reasons. And we can do a podcast on AI ethics and philosophy later. Right. But digital twin will help this industry continue to grow without necessarily having to expand other areas of disciplines at an equal rate, which makes us uncompetitive.
The potential is I think it's one of the most powerful in a world full of powerful opportunities.
Yeah.
From a practical perspective for me, where I see a challenge is when I think of a data center, even a mega data center, hundreds of megawatts, the framework of it, if you will, whether that's the gen farm, the UPS infrastructure, such as it is, maybe that all goes away. But the bones of the thing. There's a few of those, but the things that go in the data center to simulate all the things that you're talking about, to this day, with the most sophisticated buyers and deployers of IT gear that I know, their asset management challenges are still spectacular challenges. And so where this works, obviously, if your data lake is not accurate and complete, that right there's the challenge. So it is in parallel with all the compute power in these tools. If my data as we have heard a million times, is not as accurate as it needs to be, we've seen hallucinations, not just AI hallucinations, but in real world examples, hallucination.
For sure.
We go to do an MFD or something, and why is this behaving in a way that we didn't expect? Only to find out the tiles that got swapped out by Tom were perforated differently, or the rack is whatever, any of these million things. And so you've got to have that integrity, and we're working on it. I could tell you all the integrity of the bones, because it's much less sophisticated because they're big components and they're like this. But when we get in that minutia, I'm sorry.
But that's exciting, Dave, right? So if you think about it, most everything we put into a data center today is IoT enabled to some degree.
Sure. Yeah.
Most everything.
Right.
And asset discovery is absolutely the holy grail, for sure. But in the future, these AI-driven digital twin capabilities, they'll start to learn this as well, right?
Yeah.
So you'll say to your digital twin, Tom will change the floor tile.
Yeah.
Something will happen. The digital twin will say, "Ooh, interesting! Something's difference going on in the room."
Yeah.
It won't maybe understand what the floor tile is, but then you'll tell it we change the floor tile, and the digital twin will then know this.
Right.
And then the next time it sees maybe a similar anomaly pattern, it'll say, "Oh, you might want to check perhaps a floor tile issue, or perhaps an airflow issue, et cetera, et cetera." Yeah. So that's part of the promise. But I think you're spot on. You're absolutely spot on. The data quality.
Yeah, for sure.
Rich data is great, but if it's bad rich data, it's
just bad data.
It's just bad data. So asset discovery is still very much the holy grail, and it has been for DCIM for many, many years. And I think we're getting towards solving that.
What I love about all of this stuff is we keep talking about all these hard things, but if you're curious and you like to work hard, there are so many jobs. There's so many things to build this infrastructure. There's ways to invent. How do we ingress gear that comes from people, that lands at a dock, that is automatic, RFID, future technology to be determined, whatever, identified tag. They do it in material handling places now. It goes to where it's supposed to go. There's the occasional exception. It gets to where it's supposed to get to. It gets plugged into either no UPS or a micro UPS, fibered up, electrons are moving, packets are flowing. Like there's equal to humans that are going out and spot check. We want to get to the day where I don't have to have half a dozen people walking my roof in Atlanta in the summer looking for thermal anomalies. I'll send drones up there with IR looking for that. And then when they see something weird, they're not going to send a robot up there. They're going to send a couple people up there to resolve it. And that's exponentially more safe. It's more effective. We're going to run out of time. So how do you imagine with all of this conversation the near-term or maybe medium-term impact of regulation is going to be, whether it's energy, whether it's efficiency, whether it's scale, speed, geographic location? What does that look like on the horizon as you're contemplating it?
Yeah, regulation is a really tricky topic, because regulation is a potential for arbitrage, right? So some countries regulate more aggressively or differently than others, and we may end up in a situation in the future where regulation, drives the adoption of technology in certain geos versus other geos. And I could talk about the AI Act on a whole other podcast. But when I think about regulation, I think about the regulation that we're going to be dealing with is the regulation around the impact we're having on society, right? So there's the resource impact, water and energy. No doubt we're going to have regulations around water and energy. We're going to see more and more. And right now, Dave, they're very coarse instruments, but we're going to see a lot more regulation where we will have to, as an industry, demonstrate good husbandry of the energy we're using. Because just because it's renewable doesn't mean we should waste it. So I go back to what I said earlier. Every watt matters. Every single watt matters, and we're going to have to account for every watt. So and the same for water. So that's one area of regulation that we see it in Europe, we see it in some of the Asian countries, and we see it emerging in the US. The second part of regulation is kind of a little bit more interesting, and it's a little bit nuanced. Data centers they really are the beating heart of economies now. Mm-hmm. So they're potentially failure of data centers is a systemic risk to economies. And I think governments, and we saw it in the UK where they've declared data centers to be critical national infrastructure, with requirements for reporting on how you run the data center, how you manage risk in the business, and how you document your business continuity planning, all of that. That's coming. That's without a doubt coming. And I think that, again, countries will absolutely take a different view on it for sure. But the criticality of data centers in our economies is becoming more and more evident. And the banks have a lot of experience, because the banks had to deal with this with the whole Basel regulation framework about 10, 15 years ago when they started discussing it, as they put more and more data into smaller and smaller number of data centers. They were considered systemic risks. So I think that kind of regulation is going to expand beyond beyond where we are today. The last piece is, it's more about social value as opposed to hard regulation. But I think as an industry, we have to continue to pursue this objective or this goal of making sure that the world at large, humanity at large, understands the value we bring to the world, so that we're seen as a positive. Right, because I come across it, and I'm sure you do too, where people talk about data centers are bad and data centers are using all the energy, which is patently not true. Right, it's just not true. So I think governments and regulators are going to have to help us a little bit on this journey too. Right, they're going to have to make sure that the public at large understand that the reason for regulation is because we absolutely have to have data centers for all of these reasons, and they add value to us for all of these reasons, and they're part of our community for all of these reasons. And whether that's a microgrid or district heating or helping jobs or education, whatever it is, but all of those things will play into some sort of a relationship with government agencies or elected bodies to make sure that our impact is understood. So they're the three things. Like, one is going to be on the resource management, one is going to be on the criticality, and the final one is going to be on the social value. And I think that will all come together, and that will mature in different countries at different rates, but that's where we're headed.
What do you think our call to action then is if we're in this either directly or just associated with the industry? What's if you want from this conversation today, what do you want someone to take away, Wilmer?
Yeah, great question. I mean, for me, how I feel about it, right, and I go back to the curiosity thing. I'm absolutely convinced that innovation will continue to drive our industry. The biggest challenge we have today I feel is to get closer to the energy industry, and make sure that we're continuing to do what we can to accelerate the onboarding of renewables, and we're continuing to do what we can to meet them in the market, with our requirement and understanding their ability to meet the requirements. So this kind of collision is probably the wrong word, but this continued coalescing of the data center and the energy industries, I think, is part of what the future will be. Today, we're probably not where we want to be for a whole number of reasons that we couldn't have predicted. But I'm pretty confident in the future, either through energy efficiency or renewables or smarter workloads or digital twins, dare I say it, we'll get to a better place, and we will be able to continue to support this industry and be on the journey with the rest of the planet around the climate goals for 2040 or 2050, whichever ones a particular country or a particular body is pursuing.
Well, thanks. We've covered a wide range of topics. So I'm going to let you go. One of my call to actions for everybody is, whether you're in the space that we talked about today or you're adjacent or in the midst of this, there's a reason why you want to be part of our industry. And all I'm asking, there's a philosophical thing, a religious thing out there that says, always be prepared to give the answer for the hope that lies within you. Why do you, so as you articulated this with energy, getting close to the energy industry, that may not be the same for every engineer or, interested bystander, but there is a reason why they, like us, agree this critical infrastructure is so important to human flourishing in every way. And AI is an amplifier. It can amplify things for good. It can amplify things to work against us. And so why is it that you want to be part of this industry? And then just be prepared in your own words, not how you and I would say it. This is why I want to get closer to the energy. This is why I want to get closer to whatever these components are. And you will persuade people to listen to you, hear our story, maybe join our industry. I hope we get more and more, not necessarily trying to be an evangelist as we are, but just in your own micro way. This is why I think this is important. So hopefully our audience gets some of that today. Ciaran, thanks for coming on.
No, thank you, Dave. It's been a pleasure. It really has been a pleasure. And I would also say that, this kind of interaction, it also helps people, it helps me crystallize my thoughts as well. So super opportunity. I'm delighted to have had the time to talk to you.
Well, thank you so very much for joining us today. And hey, if you guys liked it, click the like button. And if you loved it, subscribe. We'll see you next time, everybody. Have a good one.
Take care. Ciao.